Good. How are you? So, do you want to start with a prayer? Do you hear me?
Yeah, I can hear you now.
Okay. Awesome.
Sure. Do you want me to say it or do you want me to say it?
I would prefer you because here are lots of people.
Our dear Heavenly Father, we're grateful that we can meet tonight for math class, and we ask Thee that we have Thy Spirit to with you, so that I can understand and be able to retain the information. And we're grateful for the school and for Thy gospel, and I say these things in the name of Jesus Christ. Amen.
Amen. Thank you. Okay. So first of all, do you have any questions?
Yes, a couple. I didn't get the message to meet today until today. So I have not been able to do the preparation yet.
Okay.
So I was wondering if you could walk me through a few of those,
Yeah.
and then I guess
Yeah, for
through a
sure.
few, yeah. Um, oh, um, I did have a few like technical questions for assignments and stuff. For this, do I need to submit this video? Like, do I need to get the link from you?
Yeah, I can give you the link or whatever, because I'm grading that. It's just for sister. I'll just give you the link in the feedback, just in case you need it.
Sure.
Okay.
And should I just do the group quiz by myself tonight and submit it, and then my normal group will also do that?
Yeah, preferably.
Okay, that'll work. Okay.
And also, so I have only 1 hour. I'll have to leave at 7. But if you
Oh, no
don't
problem.
cover everything, we can meet some other day too.
Okay. Yeah, that'd be great. If we could cover, like the general stuff.
Okay.
For this week for the quiz and stuff, that'd be great.
Awesome. Then I'll go to the preparation.
Okay.
Right. Week 10. Week 10. And preparation. Is it for lesson 1 and 2 or for lesson 2 and lesson 3 and 4?
3 and 4.
Okay. So let me just do the screen share, I think, so we could see what I'm doing. So first question is, show the following equations are not identity. Do you understand the first one?
That's what I'm looking at right now. Oh, I might have just closed it. Oh, dang it. Yeah, let me pull it up again.
Okay. Do you see my screen?
Yeah, it's all really small though. So
okay.
Yeah, I'm just. Okay, so it has cosine A or alpha plus beta equals cosine alpha plus cosine beta.
And they say show the following equations are not identity.
The which ones?
The one that you read just now.
Okay. Because there's one like that, but it's a little different. Is that right?
Yeah, because there is actually a formula for cosine alpha plus beta, and it's not the one that they showed. I mean, it's not cosine alpha plus cosine beta is it's cosine alpha times cosine beta minus sine alpha times sine beta.
Okay, right.
Do you have these formulas?
I have them somewhere. Let me try and find them.
Yeah, you could either go on the internet and say sum and difference formulas. difference formulas, trig, and here they are. Do you see them?
Okay. Yes, let me. Yeah, actually, I can see that pretty good. Okay.
Okay.
Okay, so
So you have cosine alpha
normally
plus
cosine
beta.
alpha.
Hmm. So it should look like that, not the one that they said.
Right.
So you cannot just distribute cosine to this. It's not. It doesn't work like that for trig identity. It should be something like that.
Gotcha. Okay.
Okay, and now next one is cosine 2 theta. It's also the formula. So you cannot just pull out this 2 and move it to in the front. It's not how it works for trig identities. So let's find an internet double angle identities trig here. So we have cosine 2 alpha. Do you see?
It's pretty small. So anyway, zoom in a little bit.
Let me
Or I could
this
try.
one. And also you can click on me and it will become bigger. You know, here on your
Uh,
screen. Uh, like that.
oh, okay. Yeah, I think I got it. Okay.
Did you get it? Okay,
Yep. Okay, now I can see. Thanks.
awesome. So yeah, so this was what cosine 2 alpha equals to. So it's either cosine squared alpha minus sine squared alpha, or 2 cosine squared alpha minus 1, or 1 minus 2 sine squared alpha. It's just the formulas, the identities that you should know. Okay,
Okay.
now review the sum and difference, double angle and half angle identities from the identity sheet. Notice that you need to have memorized just the double angle identities for the sine cosine function for identities in the resource for.
Is that the sheet from the resources from the last meeting, the first thing, first meeting?
Okay, do you have that sheet?
Yeah, I'm trying to. Let me find that real quick.
Yeah, I'm trying to find it too.
All the school sites are running really slow right now.
Yeah. Let's see, so it should be something like that. Um, okay, I think I found it. So it's in the week 10, preparation 1 to lesson 1 to preparation. And if you go, there's trigonometry.
Oh, okay. Yeah, I
Okay.
pulled that up yesterday. I need to save that before
Yeah.
I use it.
Yeah. And they said that you have to learn double angle identities and for sine and cosine, not for tangent. So you just need to
Okay.
know this. Okay.
Okay. Yeah, let me pull up the sheet again here.
Mm-hmm.
The identities. Okay, so the sum difference cofunction, double angle identities, right?
Mm-hmm. Double angle identities. That's what
And
you need to
the
learn.
first four of them.
Uh-huh. Exactly.
Okay.
And also they said to review, this is sum and difference identities, and then we have half angle identities. It's just the formulas. So now use the identities to simplify. No, it's not this one. We are here. Let's move on to the third question. Using the sum and difference identities, answer the following questions. Okay, so we have let's go to paint.
Okay.
Can you try to think of which identity to use to solve this?
Let's see.
So I have
Okay, so the first one is oh yes. So these are all sum and difference for number 3. It says right.
sum and difference. Exactly.
Okay, so this one would be
Sine 47 sine 2 plus sine 47 sine 2. Okay, so which one of them? What will be? So we have cosine. Wait, no, this is not the one that we want. We want product sum identities. Because you see, um, cosine
product of
times
sum.
because we have cosine times cosine here.
Okay.
Here, cosine times cosine. So let's work on this one, the first half of the problem. Cosine 47 times cosine 2. Tell me what it will equal to using this formula.
Oh, sorry, I'm just writing down. I'm trying to catch up.
Okay, yeah, just let me know when you're ready.
Okay. Sine 47. Okay, product of sum.
Uh-huh. And we have cosine times cosine. Because here, cosine times
Oh,
cosine.
so it'll be the fourth one.
Exactly.
Okay, so it'll be cosine A cosine B equals 1/2 cosine A minus B plus cosine A plus B. So then plugging the numbers in,
Exactly.
it'll
What
be
we'll get.
47 times cosine.
Wait. Cosine A minus B. This
Oh,
is
I
A.
was plugging in the left side. Sorry.
Okay.
So 1/2 cosine. So then it'll be 47 minus 2.
Exactly.
And can I just like put it in that way as like 45?
Yes.
Okay.
This equals to 45.
Plus cosine 49.
49 exactly. Okay. So this one is the first half of the equation. Let's do the second half of the equation. Sine
Okay.
times cosine. So which one of them we are using?
Sine times cosine will be um, product of sum. The first one.
Yes, exactly. So we have plus here. So let's write down plus. What?
So A plus B again.
Kind of thing. So it's 1 over 2. 1 over 2 sine A plus B. So what it will be?
It'll be. So I'm trying to write this all down. It'll be the 49 again.
Exactly.
So it's kind of reversed.
And then what plus?
Plus sine 45.
Exactly. Okay. Now let's calculate.
Okay, so the whole thing is each equation and then added together.
Uh-huh.
Okay.
Let's distribute 2. Let's distribute 2. Oh, 1 over 2, sorry. 1 over 2. So we'll get what?
Distribute it into. So then it'll be like 1/2 cos 45 cosine.
Exactly. Exactly.
So 1/2 cosine 45 plus 1/2 cosine 49.
Exactly.
And then plus, do the same on the other side.
Mm-hmm.
1/2 sine 49
Exactly.
plus 1/2 sine 45. Okay.
Mm-hmm. Okay. Okay. Let me go to um check our work so far. Um. Something's wrong. Wait. Oh, I see what's wrong. We should have used some indifference identities. Sorry.
Oh, okay. So it
Because
was an
that,
difference.
that would be easier. Because we have cosine times cosine plus sine times cosine. Sine times cosine. See, times sine. Did I write the problem right? Um,
Let me get a new page here.
that's weird. So on this one they got cosine times cosine plus sine times sine, but on this one sine times cosine. So here's the mistake in the program.
Oh, the problem's not right?
Yeah, you see, in a lesson preparation it says cosine too. Then when you go to the keys, it says sine instead of cosine here.
Oh, okay.
And this
That
one actually would make sense. Then we could actually use the formulas that I told you. Um,
so
this
it's
is some
cosine.
difference. So it's
Uh,
actually sine here. Um, this one is sine. Sine.
okay, so it's the second one then?
Yeah.
Okay, so
Let's see.
cosine 47 cosine 2 what, minus?
Wait, it's not the second one because there is minus, but we have plus between them. So it is.
Okay.
So it's the fourth one.
Okay, plus sine 47 and sine 2. Okay, so the fourth one. Okay, so then, oh, so the whole thing's gonna be equal to cosine a minus b.
Exactly. So you have cosine of.
Oh, so it'll be 45.
Exactly.
Oh, okay, that's not that hard.
Yeah, looks much easier.
Yeah.
2/2. Hmm.
Okay, that makes sense.
Okay. Oops. Where?
Oh, and then there's the second one.
Second one. Let's do the second one. So it will be. So we have um, sine x times cosine 2x minus cosine x.
Oh, okay, so it looks like it's the third one.
Let me check the third one. Sine times cosine minus cosine times sine. Exactly. Awesome.
Okay, so then it will be sine x minus 2x.
X minus 2x.
Ah,
Awesome.
okay.
And then what we will get then?
Oh, I think that's when you have a negative inside, you move the negative out. Wait, hold
Exactly,
on.
exactly, yeah. So it will be
Right? Oh,
sine of
because it
x.
would have been a negative one.
It wouldn't be in
Negative.
sine of negative x, right?
Yeah. Okay.
And then if we look on even odd identities, we see that you can just pull out this minus for
Negative. Then
sine.
it's negative sine of x.
This is the answer. Let's see. Awesome. Okay. Now find the exact value without using calculator.
Is that using a unit circle?
No, because 75 degrees is not um, defined on the unit circle kind of thing.
Oh, okay.
So we have
You
cosine
know, should
75.
we find it without a calculator then?
No, no, no. They want you to use identities to figure that out.
Oh, okay, okay.
Hmm.
So then it's
Let's see what we
oh,
can use. Hmm.
so then we would use reciprocal.
Let's see. 90 minus 75, 15 degrees. No, not the reciprocal, but something with some different identities. Right?
Summon different.
Uh, we can say that 75 is something plus something. The values that we already know, or
Oh,
something
okay.
minus
So,
something.
so it would be uh, okay. So cosine 75 would equal cosine A cosine B minus sine A sine B. Or yeah.
Yeah, but 75 is what plus what?
Oh, we don't know, right?
We can just say 45 plus 30 degrees.
Oh, you can just make it any number that adds up to it, or
Yes, yes, but not any. The one that is defined in a unit circle. If we look at the unit circle.
oh, because it's like by 15 degrees. Is that right?
So the only degrees that are defined is 30, 45, 60, 120, 135, 180.
Oh, okay, yeah. There's no 15 to go with 60, so it'd have to be 30. Okay.
30 plus 45, those are the
Yeah.
defined ones.
Okay,
Okay.
so equal
And then
cosine 30 plus 45, and that would equal.
I would equal to what formula are we using? Cosine 45 plus 30.
That would be the second one of sum and difference, right?
Exactly.
So it'd be cosine 30.
Cosine 45, you mean?
I just had 30 first. Should it be 45 first?
No, doesn't matter. Let me set up like you set it up. 30 plus 45. Okay, 30. And then
Oh, sine. So it's cosine 30, cosine 45 minus sine 30, sine 45.
exactly.
Okay, interesting. Yeah, I didn't know about the splitting to fit the unit circle, but that makes sense.
Yeah, because we don't know 75, but we know 30 and 45. We could figure out with the help of these formulas. And now let's substitute. So let's find cosine 30. Cosine 30. What is the cosine 30?
Cosine of 30.
Mm-hmm.
Let me pull up my unit circle too.
Mm-hmm.
Cosine comes first in the ordered pairs, right?
Exactly. Represents x
Okay,
value.
that would be square root of 3 over 2.
Exactly. So we write down square root of 3 over 2. times. We did this. Now let's figure out cosine of 45.
That'd be square root of 2 over 2.
Yes.
And then we multiply those.
Uh-huh.
Okay. So when you're multiplying across with two square roots, how does that work?
So when there's multiplication, you multiply square root of 3 times square root of 2 and 2 times 2, right?
Okay.
So since here's square root and here's square root, it means that they are like things. So you can multiply 3 by 2. It will be 6, and you put square root there.
Oh, okay.
And,
So it's just, okay.
and then 2 times 2 is just 4.
Interesting. Okay.
And then minus, let's find sine of 30.
Sine of 30 equals. Okay, so that'll be the y in each.
Uh-huh, exactly.
Sine of 30 would be 1/2.
Exactly. And then sine 45.
Would be also square root of 2 over 2.
Yes.
Oh, okay. So then you multiply those together.
Uh-huh, yes. So you get 1 times square root of 2, which will be just square root of 2.
So square root of 2 over 4.
Exactly. You have minus.
Oh. Okay, so then you subtract. So you have square root of 6 over 4 minus square root of 2 over 4.
Yes. And since they have the same denominator, you can subtract numerators. So you will get
Oh,
what?
so then it would just be square root of 4 over 4?
No, square root of 6 minus square root of 2 divided by 4.
Okay.
So the thing is that when there is multiplication, then yeah, you can
Oh, okay.
multiply. But then when there is subtraction, you cannot, because there's a such formula like square root of a times square root of b equals square root of a times b.
Okay.
There's
But with addition and subtraction, it's different.
It's different, yeah. You cannot add or subtract them
Okay.
unless here was the same number, square root of 2 minus 2 square root of 2, it would be negative square root of 2, but it's different. That's square root of 6 minus square root of 2. Okay, so this is the answer, and let's check that. Um, Square root of 2. Okay, so they used instead of square root of 2 over 2, 1 over square root of 2. Let's see what it will give us. 1 over square root of 2, and then we have minus 1 over 2, 1 over square root of 2. So it will be square root of 3 over 2 square root of 2 minus 1 over 2 square root of 2. The denominators are the same, so we can add numerators. So it will be square root of 3 minus 1. Oops. Minus 1 over 2 square root of 2. So this is the same answer, but instead of square root of 2 over 2, they used 1 over square root of 2.
Okay.
But it's the same thing. It's just radical is on the bottom.
Could you scroll over again so I could see the
Like
answer?
that?
Yeah. So it'll be square root of 3 minus 1 over 2 square root of 2. Okay.
Exactly.
I think
Awesome.
I understand that.
Okay, let's try to do the next one.
Okay.
Tangent pi over 12. Tangent pi over 12. Okay, so let's look at our identities again. Let's make it this. Okay, so if you look at our unit circle, There is no pi over 12, right?
Right.
But if we add something to something and get pi over 12, we could figure out using the unit circle.
Okay.
Okay, so let's think what should we add. Um, so 180 over 12. So if we change it pi over 12 to the degrees, it would be easier to see what we should add to, right? Let's see. Pi over 12 is 180 over 12. So it will be 15 degrees because pi equals to 180 degrees.
Okay.
So actually they are saying tangent of 15 degrees. Now let's think. Maybe it will be something like 45 minus 30. What do you think?
That would make sense to me.
Yeah, to me too.
Those are the numbers that would be closest to 15 and easiest to use to get to 15.
Exactly. So let's say tangent pi over 4, because 45 is pi over 4, minus 30 degrees, which is pi over 6. Pi over 6 equal
Okay.
to. Or we could write it in degrees. I don't think it would really matter, but let's use this for just to make it a little different than the previous one. Okay, now let's use our formula for tangent alpha minus beta,
Okay.
right?
Um, if we're using the 45 and 30, I guess.
Yes, we are using, that's correct. Because 45
So
minus 30 is
tangent.
15. So tangent,
So okay, yeah, tangent 45 degrees minus 30 degrees. So that would be equal to, we have a fraction, we have tangent 45 minus tangent 30 on top.
exactly.
And then we'll have 1 plus on the bottom. Tangent 45 times tangent 30.
Exactly.
Okay.
Okay, so now we can do that because we know that tangent is sine over cosine. So it's basically saying so y over x kind of thing. Let's go to our unit circle. We have 45 degrees is here, and tangent is y over x. So square root of 2, square root of 2 over 2 divided by square root of 2 over 2.
Okay.
Right. So let's write it down. And then square root of 2 over 2 divided by square root of 2 over 2 is just what?
Just 1, right?
Exactly. Here's we have in 1 minus tangent 30. So it's y over x. So it will be what?
Um,
1 over 2 divided by square root of 3 over 2.
okay. Yeah.
Okay, and let's do the bottom one. 1 plus tangent 45, we know that it's 1 times tangent of 30, we know that this is this thing. 1 over 2 divided by square root of 3 over 2. Now all we have to do is to simplify it. So have 1 minus what? So we have to multiply by the reciprocal, right? So it would be y over 2 times 2 over square root of 3. Do you catch this? Do you catch me?
I think so. I'm just trying to keep up here.
Did you figure why tangent of 30 is like that?
Yeah, because it's the y over x, right? And the
Exactly.
y for 30 is 1/2, and the x is square root of 3 over 2.
Exactly. So let's try to calculate that. So we have 1 over 2 divided by, this means divided by square root of 3 over 2. And to make it multiplication, we have to make it a reciprocal. 1 over 2 times 2 over square root of 3.
Oh, okay, that's why they flip. Okay,
Mm-hmm.
I
Mm-hmm.
forgot about that. All right.
Awesome. And then what will be on the bottom?
Um, so it'll be 2 times. Yeah.
So it will be 1 over 2. It stays like it is.
Okay.
The, and then divided by square root of 3 over 2. So it means that multiplied by 2 over square root of 3. Mm. So
Okay.
this, the, the,
Oh, so
the,
it's one
the
minus
numerators,
on the top and one plus on the bottom, but otherwise it's the same.
yeah, but here's minus, here's plus. So yeah, true, correct.
Okay.
And now let's simplify it. So we will get what we can simplify here is 2 go away, right?
Okay.
And then we have 1 minus 1 over square root of 3 divided by 1 plus 1 over square root of 3. And we can make this fractional more prettier if we find common, if we find common denominator and add these.
Okay.
So 1 is 1 we would need to multiply by square root of 3, right? So we'll get square root of 3 over square root of 3 minus 1 over square root of 3, right? Because 1 is square root of 3 over square root of 3 to get the same denominator.
Okay.
And then divided by 1 is square root of 3 over square root of 3 plus 1 over square root of 3. So we have on top square root of 3 minus 1 divided by square root of 3. And then on the bottom we have square root of 3 plus 1 over square root of 3.
Okay.
Do you get this one?
I think so, yeah.
Since they have the same denominator, so we could make it 1. And we can add numerators, so it will be square root of 3 minus 1. And since here's the same denominators, we can add numerators, so it's square root of 3 plus 1. But we cannot add them because they are not like things. Here's square root.
Okay.
And now we have, so this one stays the same, so let's write it down. Square root of 3 minus 1 over square root of 3. And then times what?
It'll be square root of 3 um over square root of 3 plus 1.
Exactly, multiply by the reciprocal. And so these go away, and we are left with square root of 3 minus 1 over square root of 3 plus 1. Let's check the answer here.
Okay.
Awesome. Looks correct.
There's a lot of steps, but I think I understand a little bit now.
Yeah. Just remember about dividing fractions, which is multiplied by the reciprocal. This one stays the same, the number that is on top, and the other one is multiplied by the reciprocal of it.
Okay.
And then we first changed pi over 12 to the degrees to make it easier for us to see what we have to add or subtract from.
Okay.
Okay, and let's move on. So using the double angle and half angle identities, answer the following questions. Okay, so this one is totally exact, the same exact like the previous one. So let's do that. And you will try to do it. So we have tangent 120, okay? Tangent 120 degrees. Let's see. Let's see what we can add or subtract from our unit circle. Let's see. 120. Oh, actually, we could
Oh,
actually figure
this
out
one's
the
on
answer.
there.
Yeah, it's actually R in the unit circle, but looks like they want you um to use to find it without using and use double angle and have angle identities kind of thing.
Double angle. Okay.
So double angle, let's go to,
So would you use the tangent 2x
yes,
and just
let's
have
use it.
120 as the x?
Yeah, let's do that. So if 120, if 120 is 2x, is 2x, then equals to, it will equal to what?
Oh, sorry, I was writing down the formula.
Yeah, yeah.
So then we'd have tangent 2 and then 120 equals, so then we'd have 2 tangent 120
No,
over,
here's the thing. The 120, the whole 120 is 2x. So 2x equals to 120.
oh,
And so x equals to 60 divided both sides by
oh,
2. So
interesting.
we are actually having tangent of 2 times 60 degrees kind of thing.
Tangent 2 times 60 equals 2 tangent 60 over 1 minus tangent squared 60.
Exactly.
Okay.
Awesome. So you have 2 times. Let's figure out what tangent 60 is. So let's see. Tangent 60 is
So it would be the y over the x, right?
exactly.
So tangent 60 is equal to square root of 3 over 2
Mm-hmm.
over 1 half.
Mm-hmm. Exactly. Awesome. And then on the bottom we have,
Sorry, I'm catching up here real quick.
mhm,
3 over 2 over 1 half. So then it'll be 1 minus tangent squared of 60.
mhm.
So do we to like put parentheses squared of that same thing?
Exactly. Tangent
Okay.
square 60 is the same as tangent 60 in parentheses squared. Uh-huh.
So
So we have
squared
square root of 3 over 2 divided
1.
by 1 over 2, whole thing squared.
Okay. Gotcha.
Okay. Now let's calculate that. Let's simplify it a little bit. And what will get on top? 2 times what?
So it'll be 2 times um square root of 3 over 2 times 2 over 1.
Exactly. Good job.
Thanks.
Awesome. And then on the bottom we have,
We'll have 1 minus um
let's do in parentheses, change the parentheses first and then
okay, so parentheses squared of the same thing, right?
exactly.
3 over 2 times 2 over 1.
Okay. Now let's simplify. So you have 2 here and 2 here are gone. So on top, what, and here
2,
2
those
and
2
2 are
are
gone. So we have
okay.
what on top?
So I'll have 2 times um square root of 3 over 1.
Which is the same as just 2 square root of 3. Because anything over 1 is just the same.
Oh, okay. And then we'll have 1 minus square root of 3 on the bottom.
Square root of 3 squared. Right? Because you have
Oh,
square.
right.
Mm-hmm.
Almost forgot. Okay.
And let's simplify it further. So we have 2 square root of 3 on the top. And then on the bottom, what do we have? 1 minus what?
Oh, I guess it would just be 3, right?
Exactly, yeah. Because this one
Aha.
cancel each other out.
Tricky.
And then we have 2 square root of 3
Over
divided
negative. Oh,
Negative
yeah.
2.
Yep.
And then what do we have eventually?
Um, trying to remember what 0 to 2 is. Did it just cancel out?
Mm-hmm.
Oh.
So it
So
becomes
then,
negative square root of 3.
okay.
Yep. So remember, whenever there is the same number on top and on bottom, it can be just cancelled out.
Right. Okay.
Like here, it's like that. So this is the same number, so it just cancelled out.
Okay, that makes sense.
Awesome. So you have negative square root of 3. Let's check that. Correct.
There it
Now,
is.
now cosine pi over 8. Let's see. Cosine pi over 8.
Probably have time for one more at this one at least.
Mm-hmm.
Okay. 1 over 8. Is that on the unit circle?
I don't think it really matters,
Oh, okay.
but because we still need to use the identities. And so let's figure out
Angle.
180 divided by 8. So let's figure out first what angle it is, so we could better see it, right? So pi over 8 is
Okay.
how many in degrees?
It would be is this where we have to subtract again?
No.
Right.
We are just changing pi over 8 to the degrees. This one is in radians to the degrees. So remember what I told you, pi equals to what? Pi is 180 degrees, right?
Okay, 180. So, 180 divided by 8.
Exactly. So we have how many degrees?
So it'd be 22.5?
Yes, 22.5 degrees.
Okay.
Now try to multiply it by 2 in your calculator.
That times 2?
Yeah.
45.
Yeah.
Oh, okay.
You see, so this angle is something like x over 2 probably. Let's see, x over 2.
Oh, and that's the double angle, right? Or half
Mhm.
angle, sorry. Half angle.
Yes, half angle. And we have cosine. So you have cosine 22.5. Let's pretend that this whole thing is x over 2, right? So we have x over 2 equals to 22.5. So what x equals to?
45.
Exactly, 45 degrees. So you have actually cosine 45 over 2. Now let's use the formula. Um, the formula cosine x over 2, right?
Cosine x over 2, so that's equal to plus or minus square root. And then it's inside squared, it's 1 plus cosine x over 2.
Cosine, but in our case, it's cosine of what?
45 over 2.
Exactly.
Okay, so it'll be 1 plus cosine of 45 over 2 over 2. Okay, and that's all inside the square root.
Yep. So let's see,
Oops.
cosine 45 equals to what?
Um, oh, wait, it's only, okay, I messed up. So it's only cosine 45 inside?
Yeah.
Okay. And cosine 45 is equal to...
Yeah, because here we have where our cosine x over 2, but here's just x. So x in our case is just 45, which is on top, right?
Yes.
Mhm.
Okay, so then that cosine of 45 is square root of 2 over 2.
Exactly. Over 2. Okay,
Okay.
so let's simplify it a little bit. So to add these, we have to have the same common denominator here. So what it would it be? 1 is the same as
To get 1 and oh, we have to multiply 1 by square root of 2 over 2, right?
by 2. Just by 2, because
Oh,
we have
just by
2 over 2 is the same as just 1.
Oh, that's right. Okay. Oh, so it's okay.
Yeah, and now
Well,
they have common denominators, so now we can add the tops. And this all divided by 2.
okay, so then we'll get, and those just add across, right? Or it's like, so it's 2 plus
No,
square root of 2.
yeah,
Oh,
the,
sorry.
the denominator stays the same. We say 2. They have the common denominator, so we make it as 1. And add numerators. So it will be 2 plus square root of 2. Add
And all of
numerators.
that's over 2.
Mhm. Add top ones. And this becomes 1. And then this whole thing divided by 2.
Okay.
Okay, let's simplify it a little more. And so 2 is the same as 2 over 1. And so you tell me, what do we get? The
Say
top
that
one,
again.
so 2 is the same as 2 over 1. And
Okay.
now, what do we get? The top one stays the same, right?
Mm-hmm.
Over 2 times what?
Oh, let me try. Times, oh, times 1 over 2.
Exactly. Exactly. So we'll have eventually what?
Oh, so then we'll have the big square root, and we'll have 2 plus square root of 2 over 4.
Exactly.
Okay.
Now, we can take square root of 4. So it will be square root of 2 plus square root of 2 divided by 2. Because square root of 4 is 2. Because there's also another formula like a over b
I can't
equals
see the bottom corner because the pictures may move.
um so just this is the formula. See, so we can take separately the square root of top and square root of the bottom. So we will have square root of 2 plus square root of 2 divided by square root of 4, and then square root of 4 is 2. So eventually we'll have square root of 2 plus square root plus square root of 2 divided by 2.
Okay.
Okay, and let's check that. Um, okay, they probably again used instead of square root of 2 over 2, 1 over square root of 2. That's
Oh,
why they
okay.
have a little bit
But it's
different.
this is the same thing.
Yeah, it's the same thing.
Okay.
Okay, so um, I think I have to go soon. Then I
Nope,
will
that's
be able
fine.
to.
Hopefully I should be able to get through the. I'm gonna try and work on the quiz tonight.
Yeah, or if you want, we can meet some other time before you take the quiz to go through the extension problems. Or if you want, you can do it by yourself.
Yeah, I'm just worried because I have stuff tomorrow and then Friday, and then I'm out of town Saturday. So
I could meet later tonight, like at actually I don't know. Hmm. So I have to figure out something, and I could text you if I can today, like at 8.
I'll start working on it.
Oh yeah, or you can just start working in it, and if you have any questions, you can email me or
That
something
sounds
like
good.
that.
Yeah, if I run into something that I really can't get past, I'll email you. I can do that.
Awesome. Yeah, and I'll reply to you.
And you said you could email me the link,
Yep.
the YouTube link for this. Okay,
Yes. Yes.
thank you.
Okay. Yeah. Have a good night.
All right, you too. Thank you.
Bye.
Bye.